we will start this lesson by reviewing using a ruler. The study question we have here are what are the lengths of each line segment? You should have cut and pasted these into your notebook. The measurement here is centimeters, and in this case we're going to have to estimate how many centimeters line segment AB is. It is close to 4 centimeters, so we'll say approximately 4 centimeters. The way we write this is by noting segment AB, because this is a line segment. It has 2 ending spots, or 2 points, and it's measurable. Segment AB is approximately, this doesn't mean equal to, it means approximately 4 centimeters. But if we have millimeters, those are the little notches in between. If we have millimeters, we count. And there's 1, 2, 3, 4, 5, 6, 7. It's about 7 millimeters here. So line segment AB is approximately 3.7 centimeters, where the 0.7 represents 7 millimeters. In geometry, you're going to be given a lot of line segments that are measurable, but you won't be given all of the information. So our next question is, how do we find the total length of a line segment if only parts of the segment are given? So let's say we have an entire line segment DC, and in between we have an A. So this is point A, D, and C. If they only give us DA, which is say 3 centimeters, and AC, which say is 1.5 centimeters, how do we find the total length of the line segment? Well, in order to find the total length of the line segment, you would add the 2 parts together. So I would add DA to AC, and that would equal the whole line segment DC. So just substitute the values here. 3 plus 1.5 equals DC. So DC is going to equal 4.5 centimeters. The next scenario is, how do we find the remaining length of a line segment if part of the line segment is measured and we only know the whole length of it? So let's put a point here and say that you have D, E, and F. And let's say we know the whole line segment is 15 centimeters. And DE, and we'll show that DE is, let's say, 3 centimeters. But we don't know what EF is. Well, in order to find out, you're going to subtract the given length. You're going to subtract the given length here from the entire line segment. So if we know the whole length is DF, you're going to subtract the given part from the total length. So you're going to subtract DE from DF. That's going to give you the remainder, EF. So to put it in numbers, you're going to take the whole thing, 15, subtract the part of it, the little guy, 3 centimeters, and that'll equal the missing piece right here. So EF is going to equal 12. So now we're going to get into the math of geometry. We first have to know how to represent figures if they're given to us symbolically. So how do we draw a figure to represent XZ equals XY plus YZ? Well, if you have 2 capital letters, they represent 2 points, and 2 points are going to represent a line segment. So XZ is going to be the whole line segment, XZ, and XZ is made up of XY, so XY is somewhere in here is a Y, plus YZ. So this is the picture that represents this equation. So now let's look at an algebraic word problem. So I'd like for you to take a second, copy down this example, and we will work on it together in just a moment. Go ahead and pause the video and copy down this example. Okay, so we're going to find the value of a variable, if y is between x and z. So I know that I'm going to have a line segment where y is in between x and z. So y is in between x and z. Now I need to label the information that's given to us. xy is 3a, so I just label it above xy. That means from here to here is 3a. xz, that's the entire line segment, is 5a minus 4. And yz is 14, so from here to here is 14. In order to find a, I need to set up an algebraic equation just like this, where xz, the total length of the line segment, equals xy plus yz. So it's the little part plus the little part equals the whole thing. Now I substitute my values in. xz is 5a minus 4 equals xy, which is 3a, plus yz, which is 14. Solving for a, I can subtract 3a from both sides. So I get 2a minus 4 equals 14. I can add 4 to both sides. So I get 2a equals 18. And I would divide by 2 on both sides. So a is 9. Okay, so now I'd like for you to copy this example down as a study question. And here to the right, draw a picture, set up the algebraic equation, solve for b. If y is between x and z, xy is 6b, xz is 175, and yz is 8b. You should get that b is equal to 12.5. If you don't, or if you don't know how to solve this equation, please raise your hand and ask your teacher. Okay, our next study question is, what is congruent? What does congruent mean? And congruent just means basically the same as equal to. It means that two figures have the same measure. So we'll say two figures that have the same measure. And we show that two figures are congruent with hash marks. So for example, if I had two segments, let's say segment AB and segment CD, and they were both exactly the same length, I would put a hash mark here and a hash mark here. And because they each have one hash mark, they are congruent to each other. I could also show two hash marks. Let's say EF and GH are congruent to each other, but I don't want them to be congruent to AB and CD, so I show two hash marks. And that just means that EF is congruent to GH. The symbol for congruent is an equal sign, and then on top of that, a tilde. And since my handwriting is a mess, if you look at this symbol right here, that's supposed to be the same as that. So what does AB is congruent to DC mean? It means that segment AB is congruent to segment DC. Segment AB has the same measure as segment DC. So drawing a picture, we would draw two segments that are the same length. Label one AB, label the other DC, and we put hash marks to show that AB is congruent to DC.